Hello everyone, and welcome to today's short little module on some of the necessary chemistry essential topics that you will want to have. And these are just sort of miscellaneous ideas, but what we're going to start with are the diatomics. The diatomics are just a series of elements that exist not as what you would see on the periodic table, but as a diatomic, which means two of that unit together. And now there are plenty of ways that you can memorize this particular set of diatomic elements, but I like to do it just based on where they are in the periodic table. So if I were to just select hydrogen here, and then I went over to this side of the periodic table, and I just grabbed everything here all the way down to iodine, made this sort of upside down L shape. Those are all the diatomics. And so there are plenty of acronyms and things that will help you memorize them, but I like to just memorize them spatially. This is where they are. This is what they are. Now, I want to talk just briefly about why they are so important, because at the end of the day, you're going to need to just simply memorize them. But let's look at hydrogen. Hydrogen has a molar mass equal to 1 gram per mole, but that is for one hydrogen. So I need to multiply that by 2, and that's going to get me 2 grams per mole. Pretty straightforward stuff. So for nitrogen, for example, this is going to be 14.01 grams per mole, but I need to multiply it by 2, so that's going to be 28.02 grams per mole. And that can apply for any of these. One other thing that you might want to know is that everything from hydrogen to chlorine, so hydrogen, nitrogen, oxygen, fluorine, and chlorine, these are all going to be in the gas phase. And then bromine and iodine are the only ones that are not. Bromine is going to be actually a liquid. Iodine is going to be a solid. Now, these are all going to be covalent bonds. And so if I picked on chlorine, for example, and I wanted to draw out what's going on here, this is simply a covalent bond between two chlorine atoms. And it would look like that. And you can, of course, make the conclusion from that all of these common diatomics are going to be nonmetals because there are two atoms that are covalently bonded together. So other than just memorize these, why is it so important? And well, it's so important because of this question that I have at the bottom left, which is just that what is the mass of 4 moles of oxygen? So our basic stoichiometry tells us that if we take the number of moles and then multiply that by the molar mass, I can get just the mass that I have present. And so I can take 4 moles, and then I can multiply by the molar mass of oxygen. But notice how it just says oxygen. Are they talking about O, or are they talking about O2? And that's where you need to understand that these are always going to exist in the diatomic form. So when they say hydrogen or nitrogen, oxygen, fluorine, etc., they are telling you directly that it has to be in the diatomic form because oxygen just doesn't exist in our atmosphere as just one O atom. And so I need to use 32 for this value. So if I wanted to get a final answer, it would be 128 grams. And that's all we're going to talk about for these common diatomics, but you're going to see just how important it is for stoichiometry, for gas law problems, for thermodynamics. It's incredibly important to treat these diatomics as two atoms together to get that correct molar mass.